Hi, everyone, and welcome to the first ever live streaming of the Red Hat AI What's New and What's Next presentation. Whether you're a customer, a prospect, a partner, Red Hatter, or just plain curious, I have the best product team on the planet who is here with me and very eager to share what's new in the next upcoming release and what's next in their roadmap. Session logistics. For product related questions, please use the YouTube channel and we'll have the product managers and subject matter experts answer those questions live. For sales related questions and anything that is internal to Red Hat, obviously ask it on the Slack channel that is noted there, which is recording and slides will be available on that URL after this presentation is complete. We do this every quarter, and hope you can join us in the future. Thanks for coming today, and subscribe to the YouTube channel so that you can keep an eye for these sessions. Finally, any forward-looking statements are subject to change without any notification. Before we get to the exciting presentation, let's start talking about with the upcoming Red Hat Summit. Summit is a global technology conference where customers, partners, analysts, and technologists gather to share and explore innovations in the enterprise open source technologies. Red Hat Summit 2025 is coming up in 3 weeks in Boston from May 19th to 22nd. This will be a lovely time, mid-spring in Boston, and one of the best times to visit and experience Boston. So I hope to see many of you there. There's a URL there where you can register and find more information. Here is just a sample of Red Hat customers talking about their AI journeys at Red Hat Summit. One customer wants to provide an AI R&D team with a platform to enable rapid development and alignment of Gen AI for their enterprise use cases. They want to run these Gen AI models and applications in production on a solid platform, and they're building model as a service, on these platforms for enabling production models. Another customer here is actively developing machine learning capabilities and leveraging AI, specifically predictive AI, to enhance various aspects of their operations, including things such as predictive maintenance. Come find out more in depth about these customer experiences and many more like this at Red Hat Summit. Another key highlight of Red Hat Summit is the breakout session. Many breakout sessions, lightning talks, and hands-on labs from subject matter experts. Here's just a sampling of these. Come join them and learn about AI topics all the way from entry level to in-depth coverage. Finally, generative AI, clearly the opportunity is in front of us, and the opportunity is massive. Every customer that we talk to, is on the AI journey, with a growing number of these customers that are moving from evaluations to pilots to POCs, and from POCs to production deployments. What does Red Hat bring to the table? How do we help customers address key challenges impacting these AI initiatives? The first one is model cost. We see customers struggling with the cost of running large proprietary Gen AI models and model services, especially as they bring more and more use cases to production to run at scale. This was a driver of the work we have been doing with IBM Research since last year, and we announced the open source grant models and included them as part of the Red Hat AI platforms. And we are, and also a driver of the work we are doing with Neural Magic around model optimization. So the second is alignment complexity. Regardless of what model you choose, customers are also struggling with the complexity of aligning these models to their private enterprise data and use cases. Most are deploying a RAG-based solution with something like ChatGPT or GPT-4 rather, with OpenAI, and maintaining those data sets outside the model. We believe there's also a role for fine-tuning as a complement to RAG, and that's driven by our work on InstructLab that we introduced last year. Finally, in terms of deployment flexibility, as the number of use cases increase and customers are also realizing that they need the flexibility to deploy these models wherever the customers are and the data may live, they can't be constrained to a single cloud service, but rather need to deploy models across multiple clouds, on-prem, and even out at the edge. Much like we have seen in the cloud native space, over the past decade plus, with hybrid cloud, this is also driving the demand for hybrid AI platform. Ultimately, customers need more cost-efficient models aligned to their use cases with their data and the ability to run anywhere that they choose. The Red Hat AI portfolio helps customers overcome these challenges. For the Gen AI use cases, customers have a choice of trusted open source Gen AI models. They can align those models to their data and use cases using the RAG and fine tuning. Finally, they can deploy and scale these pipelines across the hybrid cloud. AI app developers can similarly develop AI applications and use a Red Hat AI platform for model serving endpoints. In the case of predictive AI, data scientists can work with data from different sources, train and hyperparameter tune, develop predictive models, and then deploy them in production, while also having the ability to monitor the model for performance and drift. Red Hat Enterprise Linux AI is built on RHEL as a starting point for small, skilled environments, whereas Red Hat OpenShift AI built on OpenShift provides multi-tenancy, reliability, and scale for production deployments of AI. And all of this is built on a solid foundation of RHEL and OpenShift that provide the trusted, consistent, and comprehensive foundation that span the hybrid cloud and hardware accelerator landscape, giving customers flexibility, choice, and reliability for that AI platform. So as we look towards the rest of 2025 and beyond, what are some of the major focus areas that informs Red Hat AI's roadmap? These are typically shaped by our customers' inputs, Red Hat's overall strategy, and also market trends and dynamics. Starting with the top here with models, while we continue to ship and support and indemnify newer branded models, we are enabling Red Hat AI to run third-party open source AI models. To that end, we are introducing a third-party model validation program. This will also enable customers to choose from the right state-of-the-art models for multilingual, multimodal, and for reasoning and other specialized needs. We'll introduce tools and techniques for optimizing models. Enabling customers to align AI to enterprise data and use cases will continue to be a major focus area. We'll build upon and rapidly innovate in the areas of data ingestion and chunking, synthetic data generation, training, evaluation, and RAG to help organizations align AI to their data and use cases. This includes also new things such as how to customize reasoning models and increase accuracy of models with the state-of-the-art inference-time scaling methods that you will see more of in just a couple of slides. Be it off-the-shelf models or the customized and fine-tuned models, customers are looking at how to serve these models and provide inference endpoints for their AI applications, including agents. Customers are faced with questions such as how to keep up with ever-increasing demand on these endpoints while also facing a scarcity of GPU and compute infrastructure. How to maintain SLOs or service level objectives for token latency and throughput and other KPIs. How to do all this more efficiently and effectively. And by the way, inference-time scaling and reasoning will only add to these demands. Model serving at scale with service level objectives while also enabling easy model management and deployment with model hubs and registries is going to be a major focus area for us. AI applications, especially with agents, are rapidly gaining traction in the industry for intelligent automation, and so on. So enabling Red Hat AI as a provider for some of the API endpoints that AI applications will need, such as inference endpoint or a vector IO or for tool calling, will enable our customers with a powerful platform to run AI applications for development and production. Customizing models or model serving or AI applications, any of those three things that we discussed about here, will require a robust and comprehensive LLM ops capabilities, observability into the world of AI with new metrics such as time to first token or tokens per second or cost per million tokens, and combined with existing ones such as GPU usage and showback or chargeback needs to be enabled and collected and reported on. Enterprise deployment of AI will also bring in security, compliance, and governance concerns, including model provenance, signing and encryption, as well as guardrails for safety and compliance. There is an ever-growing list of new hardware accelerators and partners that need to be enabled across the hybrid cloud. AI is built on open source, and we will continue to invest in open source communities for deploy model development, training, tools, and frameworks. Finally, we are developing a robust enterprise partner ecosystem of AI model providers, OEMs, cloud service providers, and ISVs, and these will remain a major priority for us in 2025 and beyond. So let's talk about one of the first focus areas for us, which is inferencing. Red Hat AI is on a mission to deliver any model on any hardware accelerator. VLLM has fast emerged as the de facto runtime for generative AI models. With the acquisition of Neural Magic at the start of this year, Red Hat is in an amazing position to accelerate our mission of any model on any hardware accelerator. Red Hat is already one of the largest enterprise contributors to the VLLM project, which is in turn now a PyTorch ecosystem project with a robust open source governance model. As a concrete example of this community in action, more recently, Red Hat engineers collaborated with upstream VLLM community to introduce zero-day support for Llama 4 models. Similarly, and recently, we saw the announcement of Google TPU support for VLLM at Google Cloud Next. The VLLM community, and with the help of vendors such as AWS, will continue to enable support for newer accelerators such as the AWS Neuron chips, for example. Finally, with fast-paced innovations, both at the low like CUDA kernel levels, as well, which interfaces with the accelerator hardware directly, and at higher layers of the stack, which interacts with LLMs, such as at the optimizations for KV cache, with speculative decoding techniques. VLLM has become a performance leader and has outpaced performance benchmarks for a number of models on a number of hardware accelerators over the past year. With this, I'll hand over to Jeff to talk about some of our other strategic focus areas. Jeff, it's all yours.
Okay, thanks, Tushar. All right, so looking at some of the other focus areas, we're continuing to help customers align models to their specific enterprise use cases. Within the alignment workflow, we want to be flexible. So that includes supporting not only a variety of models, but also different approaches to aligning the models with enterprise data. When you look at the workflows for RAG and InstructLab tuning, we're planning to provide reference solutions for each component that can be used on their own or as part of a complete flow. We've been active in the Llama Stack community, and we'll be including the Llama Stack API in Red Hat AI products to provide a unified interface across the different modules. The modules will be pluggable, so customers can go with our out-of-the-box implementations or integrate other ecosystem solutions using the same API. For example, for RAG use cases, we may offer a default vector database to help customers get started quickly, but they'll also have the flexibility to swap in another provider for production. To make it easy to get started with a complete solution, we'll provide a Llama Stack distribution That includes an API server and a bundle of provider implementations for the various components. Okay, next slide. Another focus area is helping customers build and run AI agents on our platform. So first, Agentic AI is really an inference-heavy use case. And because of our work with VLLM and scalable inference, we're in a great spot to support this kind of workload. Like I covered for model alignment, we'll offer a Llama stack distribution that includes a pre-configured set of components for agentic use cases, along with a unified API to standardize access to components like vector databases, evaluation frameworks, guardrails, and more. Customers can stick with our out-of-the-box options or plug in other preferred tools or services. Now, one item to call out here is our support for MCP, or Model Context Protocol. This allows models to interact with tools and external systems. For example, calling something like create a GitHub issue or send a Slack message as part of an agent's reasoning process. By providing or by supporting MCP through the Llama Stack API, we'll make it easier to integrate these kinds of tools. So overall, Llama Stack provides a consistent and flexible foundation for AI engineers to build and run agentic applications. All right, next slide. The Red Hat AI platform offers, or will soon offer, a broad set of capabilities across the AI lifecycle, including a model catalog, optimized model serving, integrated accelerator support, a foundation for building agents, and LLM ops features like model registry, pipelines, and monitoring. Our goal is to enable customers to use these platform capabilities to deliver services like models as a service or GPU as a service to their end users. Just to be clear, these are services our customers can offer using our platform. We're not providing them directly ourselves. We'll get into some of these supporting capabilities a bit more in the upcoming slides. And with that, I will pass it over to Akash.
Thanks, Jeff. So hi, my name is Akash. I run AI innovation at Red Hat. And I'm going to talk about two things, trends in agentic AI applications, and then the platform view. And I apologize right away. You have already heard the word agent at least 5-6 times. You'll hear at least 5,000 more times throughout this presentation. So just bear with me. 3 years ago, 4 years ago, if you look at the landscape, when we said agentic or generative AI applications, what we really meant were chatbots, right? Things that you could essentially talk with an LLM with. And then the technology matured a little bit more. We got to copilots. These were things that instead of just helping you with a very specific query, they could help you with your entire workflow by assisting you. Technology matured further, and now we have sort of what we call agents and multi-agent systems, where they're not just helping you with things, but they are almost able to replace part of your workflow. Okay, so with that, let me switch to the platform view of this, right? So there are basically two ways of thinking about this. You have the app deployment view, which we'll cover in a bit. I'm going to start with the app development view. So now you have decided you want to make an agentic application. Of course, you need a platform. That's what Tushar and Jeff had sort of laid out earlier. But what I'm going to talk a little bit about very quickly is sort of a toolkit for how do you go and then create agents, right? If you look at how agents are created today, it's largely, hey, you inject a prompt and give it a personality, give it some kind of a description and instruction using RHOAI or your favorite agent creation tool, right? You give some capability to call tools using MCP, etc. But largely, it is based on prompts. It sort of works when you're working with very large models, but what happens when you have a smaller model? Because large model was very costly for you, as Tushar mentioned earlier, right? So this is where this toolkit comes into the picture, and later on, we'll talk a lot more about this. But essentially, these are things like synthetic data generation capabilities and training through SFT, through GRPO, through PPO, DPO, all those technology, all those algorithms that give you the capability of creating your own agent. Okay, and then very quickly, moving on to, you had your agent, you made it, now you want to deploy it, right? Of course, again, Jeff did a great job at covering from a platform perspective what that means. But here again, and I think Tushar alluded to it earlier, there is a toolkit component, what we call the Inference-time scaling. You probably, again, one of those words that you probably heard 5,000 times if you especially came back from GDC. What it is really is a collection of tools, things like particle filtering, best of n. Think of them as without training, without changing your application logic, you are able to improve the accuracy, not just the efficiency to which you generate tokens, but the accuracy of your agentic AI application. And in a bit, I'm just going to hand over to Tushar, to Luke now, who will talk a little bit more about how that is done. So what do you, Luke?
Thanks, Akash. Hi, everyone. I'm Luke Inglis, project manager with Red Hat, working with the Akash team here today to talk about innovations coming out of the team at Red Hat AI. I want to highlight three main focus areas. The first, piggybacking exactly on what Akash was just talking about, inference-time scaling. But currently, inference is all about throughput, more queries, lower cost. But that ignores a crucial access inaccuracy. What the team really is working on is we're working to change that. We're building tools that let you get better answers by spending more at inference time. With methods like Dr. So and particle filtering, small open source models like Llama 3.1 8D can nearly match GPT 4.0 on complex financial tasks without reasoning or without fine-tuning or retraining. We also plan to introduce Squat, a KD cache quantization technique that cuts memory usage and latency while keeping quality high, again, with no retraining. Finally, on the back of what Akash and Jeff and Tushar all mentioned, inference time scaling is even more important with the rise of AI agents. These techniques let agents spend more compute on harder problems. They can generate multiple options, reflect, and choose the best one, all without switching models. This makes them far more capable in real-world decision-making where accuracy matters most. Second area of focus is customizing reasoning models. Reasoning is the new frontier for state-of-the-art models. The question we're working to solve is how can we extend our InstructLab customization capabilities to these new models? Our approach starts with synthetic data generation, transforming unstructured enterprise content into highly quality training data. These open source pipelines generate and refine domain-specific reasoning examples, teaching models not just to recall facts, but to reason through your business problems. Coming further down the pipeline, we plan to introduce async GRPO, which is a highly parallel asynchronous training method designed to dramatically accelerate how quickly reasoning models can be trained. So customizing reasoning models is coming soon, and then we plan to introduce features like async GRPO in the future. Okay, so the third area of focus is customizing Instruct models. As it stands, the InstructLab multi-phase training workflow works on base models, not Instruct models. Originally, our focus was on customizing base models because for best results without catastrophic forgetting, we needed to mix enterprise data into the instruction tuning phase itself. However, the industry is quickly moving towards more powerful, fully instruction-tuned models, and we're evolving with it. That's where orthogonal subspace learning comes in. It's a breakthrough continual learning method that enables full parameter fine-tuning without catastrophic forgetting. It introduces no additional parameters and still preserves the instruction following, safety, and reasoning abilities that define today's best Instruct models. In closing, by redefining inference, scaling reasoning, and adopting Instruct models, we're making AI more powerful, more practical, and ready for what's next. The future of AI isn't just faster, it's smarter, and we're trying to lead the way. And pass it off to Tushar.
Hi, William here. So what are we delivering in 1.5 in RHEL AI 1.5? So with RHEL AI 1.5, we bring first an updated student model with improved capabilities to work with structured output. And this is part of the feedback we received. So yes, we improved the structured output. And we also add a new Instruct, or we are using a new Instruct dataset to improve in enterprise use cases. And this release as well as we are GAing hybrid chunker to improve contextualization of the extracted knowledge from documents. And we have expanded the eval library to include industry leaderboard B2 evaluations. On training,
what you will find is that now we support Liger kernels. This is a cross-platform NVIDIA and AMD collections of optimized trial kernels for efficient LLM training. The Liger kernels increase the training throughput and reduce memory usage for up to 60% compared to standard implementations. For future releases, you see we are bringing collections of new agentic SDG pipelines. We are moving to a Python SDK first approach, and we are extending multilingual capabilities. Let's hand over to Jenny.
We're excited to announce Llama 3.370B Instruct as a new option for teacher models in RHEL AI 1.5. This is a model identified by our team for its strong multilingual and overall synthetic data generation performance. We've optimized the pipeline and CLI to make swapping teachers an intuitive experience. As part of our broader effort to bring more optionality for our customers, we look forward to adding more support for third-party models in the future. With that, I'll pass to Jaylung for expanding on multilingual support.
Thanks, Jenny. We're also actively working on extending the multilingual capabilities our model customization toolkit and pipelines can support. While in dev preview with RHEL AI 1.5, we continue to improve the support for Spanish, German, French, and Italian so that you can customize models with your data in the native script for these languages. In the second half of the year, we plan on extending these multilingual capabilities to languages that use non-Latin characters, particularly Japanese, Hindi, and Korean. Excitingly, as we are also making our pipelines more modular and customizable, we are able to provide the capability for our users to bring their own student and teacher models. This is especially pertinent for unlocking even more multilingual use cases since you know your data best, you know, and you can test which model will work for your data and your language. And so we will be providing Jupyter notebooks for these workflows so you can experiment and take these use cases to production in a familiar format. And I'll hand it over to my colleague Aditi, who will talk about innovations in the SCG space. Thanks, Jaylung. For any real-world production use case, scalability isn't optional, it's essential. Hence, we are introducing subset selection as a feature in dev preview. When users' dataset becomes large in size, subset selection allows to meaningfully find a small and diverse dataset that is representative of the original dataset. But why is this important? This allows us to reduce data redundancy and support efficient training by reducing dataset size without any significant loss of information. Imagine having to wait for synthetic data generation for 2 days or for training to finish for 2 weeks. That is what subset selection solves for our customers. This feature has entry points as a standalone Python script as well as a Python API way of accessing it, and you can try it out in our InstructLab SDG library upstream. Next slide. In the age of AI, where data is the new oil, preparing data can be challenging. Almost all enterprise organizations have vast amounts of data. Labeling these structured data still remains a monumental challenge for these organizations. Hence, we are introducing a synthetic annotation capability that transforms the daunting task of multilingual classification into a streamlined process. This allows to rapidly generate richly annotated datasets at scale, enabling high performance model training, even across hundreds of classes. Unlike traditional NLP tools that struggle beyond 10 to 20 labels, our annotation allows complexity and can deal with hundreds of labels, harnessing the power of large language models. With annotation, we are also positioning SDG, synthetic data generation, to do more than just generate, but annotate. We allow users to annotate or classify their custom data. As an example, consider a banking organization which receives influx of customer queries and they want to annotate their data for issues like fraud, loans, accounts on a daily basis. In this example, the end user will already have a big data set of customer conversations and queries, and they just want to classify their data. So how can this be enabled for the users? User brings their data set, the labels that they want to use for annotation, and some task description for the language model to just run annotation. If you want to try this out today, you can with our notebook for annotation in upstream InstructLab SDG. Please try out this notebook for your enterprise use cases and let us know your feedback. Moving on, I would like to pass it on to William, who's going to talk more about model customization with our SDK-based approach.
Yes. So what's next for RHEL AI? So let's start calling it Red Hat AI model customization. Because for upcoming releases, we're working on a new modular architecture focusing on the AI researcher and the data scientist exploration and development flow. To achieve this, we're adopting a Python SDK first approach, where we are going to provide reference Jupyter notebooks for common use cases. All this while providing the freedom for experimentation and integration of your own tools in any part of the flow. The modularization includes document pre-processing with Dublin and reference notebooks for other community tools. Multiple optimized and composable SDG pipelines per goals, per use cases. Advanced fine-tuning techniques for reasoning, preference tuning, and many others. Extending the evaluation capabilities to cover multilingual knowledge, reasoning, coding, human alignment, tool usage, and much more. With this new approach, we plan to have a subset of validated Jupyter notebooks that will be distributed as Workbench images, so you can use them on RHOAI as well to accelerate the time to value for our customers. Next, let the view with.
Hello. So, building on to share our view on our mission to support any model on any accelerator, we'll now highlight the new accelerator we are integrating into a Red Hat AI product. So, we are expanding accelerator support across all the Red Hat AI portfolio to deliver even better performance for your platforms. So first, we were already supporting NVIDIA GPU, but we are extending Red Hat AI on OpenShift AI to support the Grace Hopper platform. So supporting not only x86 platforms, but also supporting the ARM NVIDIA Grace Hopper Superchip. So it's an ARM CPU providing high performance with massive memory bandwidth on the tight CPU integration in a same SoC with a CPU on the GPU. So this type of design accelerates all the modern AI platforms, and we are bringing this support in Red Hat AI. So starting with RHEL AI 1.5 and extending after to OpenShift AI second half of 2025. Speaking now of AMD, we have provided in OpenShift AI 2.16.1 the support of AMD GPU, and we will also extend the support for RHEL AI GA, supporting currently the MI 300X, and during the year extending to the MI 325X. So it's H-weight GPU with large memory. And also speaking of a new accelerator, we'll introduce before the summer. So the IBM Spire AIU that was supported in OpenShift, and now that will be integrated in Red Hat AI. So we're starting to support this accelerator for model serving only, with a plan to support IBM Spire AIU in OpenShift AI 2.21 and also extending later to RHEL AI. Next slide, please. So to get the best of your AI accelerators, you need also the best inference engine. So we are excited to unveil the switch in RHEL AI 1.5 on OpenShift AI 2.20 to the new VLLM V1 scheduler. So the VLLM release is still 0.8, but the scheduler is switching to this new version, which is really a major upgrade to the core architecture of VLLM. So the VLLM V1 scheduler is a result of more than 1 year of development, during which all the community and the contribution of Red Hat has allowed to learn on using all the success and all the requirements coming. So with this new V1 scheduler, we have fully re-architected the core of
VLLM, bringing a cleaner and more modular design that integrates critical performance optimization across all the stack on the design. So the main goal of V1 are to provide a more modular design with easy to add code base, also ensure the high performance with near zero CPU overhead for throughput, combine key optimization into a fully unified architecture and require zero configs by enabling feature and optimization by default. So as a user, you should not see any difference for the user level API outside of the product. Same for model compatibility, GPU kernels, and all utility functions remain intact. But under the hood, the scheduler, the memory manager, the model runner, the API server have been entirely reworked for performance and maintainability. We are also introducing an improvement in speculative decoding and also offering increasing of performance. So we have prepared a blog post that you can find on developer.redhat.com called Performance Boost in VLLM 0.8. And you will see some numbers with, for example, 24 improvement in throughput with this new V1 scheduler. With that, we hand it over to Jeff.
Okay, very good. Thanks, everyone. So now we're going to get into what's new and what's next for OpenShift AI. So this is an overview of the last 3 OpenShift AI releases. I'm not going to get into the details here. We're going to cover some highlights in the next few slides. As you can see on this slide, we do monthly OpenShift AI releases, and one release each quarter is designated as a stable release, which is supported for 7 months. Our last release, 2.19, which was released just a couple of weeks ago, is a stable release. And with that, I'm going to pass it over to Kazia.
Thanks, Jeff. So first we have support for AMD GPUs. This functionality will include out-of-the-box support for AMD ROCm stack within a Workbench image. So this toolkit will allow users to optimize their AI and ML workflows on AMD GPUs. Additionally, we'll provide VLM runtime for AMD GPUs with tested and verified training and tuning images with ROCm. For example, we both have the PyTorch and TensorFlow image that are compounded with the ROCm stack to process large data sets, train deep neural networks, and provide complex inference tasks. So supporting for both AMD GPUs and these Workbench images gives customers an additional option to improve performance for compute-intensive activities. I'll pass it to Adam.
Hello, everyone. We're very happy to announce that our partnership with NVIDIA is continuing, and we have GA support for NVIDIA NIMs inside of OpenShift AI. We have our metrics going to Prometheus, performance dashboard, and we're working on improving the user experience as well. NIMs are an area that is evolving for NVIDIA, and we're looking to maintain our compatibility and support for that as we move forward. Next slide. In the what's next category, we have OCI containers for model storage in model registry. Not only OCI containers, but we're going to be enabling S3 as well, although OCI provides a whole bunch of benefits to our users that they will realize over coming quarters. So model registry started as a simple metadata store, and what we heard from the field and from our customers was, we also want to be able to have a storage solution associated with model registry. So we've chosen to go with OCI compliant storage solutions, for example, Red Hat OpenShift AI. And this is going to allow customers to easily share models between their organizations, between their departments. And it also is going to hook into model catalog, which we'll talk about in a little bit. And with that, I'm going to hand it off to Christoph.
Thanks. So I'd like to talk a little bit about new capabilities we have added. We have heard in the past few slides that GPUs, accelerators are very important. For most of our customers, they are huge investments. A GPU is a costly resource. And we would like to provide capabilities to our customers within the Red Hat OpenShift AI platform to leverage that investment to the best. That is why we have introduced the Kubeflow Trainer-based multi-node multi-OpenShift node, and multi-GPU training capabilities. So with Kubeflow Training Operator and the PyTorch framework, we extend our training capabilities to multiple nodes and to new frameworks like PyTorch. In the past, we have had the RHEL framework for distributed computing. Now we have also PyTorch. This is specifically targeting the data scientists and AI engineers communities to increase the efficiency of their work. On the next slide, I'll also go a little bit into the topic of large language model evaluation. If you train something, you need to evaluate if that training job was a success. That is why we provide all the capabilities to evaluate the large language models on your platform. We are looking at industry standards like LLM evaluation harness, at Unitext, and try to integrate them into the workflow of our customers. The mod of a data science notebook in a data science project or part of a data science pipeline. The goal is really to improve the quality as early as we can, to be as cost efficient as we can. That's it from my side. I hand over to Miriam.
Thank you so much. So also to help our customers tackle the challenges of Gen AI adoption, we can now have InstructLab on Red Hat OpenShift AI. This is important because now users can customize LLMs using InstructLab models in a scalable, distributed way, and with the hardware of their choosing for very specific tasks. We deliver an out-of-the-box pipeline that showcases some of these models to customize an LLM in an innovative, collaborative way. In the future, we will give more control and flexibility to the AI researcher or data scientist with a more modular approach in architecture and more configuration options so they can have all the tools they need to customize LLMs. I will pass on to Adel.
All right, thank you, Miriam. So we recently introduced the Guardrails Orchestrator GA. We've seen customers trying to take their models to production. However, they face a problem which we call the lost lab problem, which is basically how do you take a model reliably and safely to production? The orchestrator kind of like solves this problem by sitting in between the model and the end user. It filters inputs and outputs based on configurable rules, whether it's regex or custom detectors, or third-party validators, or even guardian models, before anything leaves the system. This reduces the need for ad hoc model patching during runtime, manual review cycles, or blind trust in the model's behavior. After all, models can still exhibit immersion behavior, and we need to be guarding them against that. The orchestrator is brought to you by the Trust AI operator, which is part of OpenShift AI. I'll hand over to Dev to talk more about the hardware profiles.
All right, very good. Thanks, Adel. In the 2.19 release, we introduced the hardware profiles feature as a tech preview. It allows users to target specific nodes for workbenches and serving workloads by using node selectors, and it supports both accelerator and CPU-only hardware configurations. It replaces the accelerator profiles feature and the container size field in the workbenches and serving UI. It has an admin UI for OpenShift AI admins to configure hardware profiles, and then they're available for selection in the UI for workbenches and model serving. Just one note that as a tech preview feature, this can only be enabled via feature flag because it affects existing accelerator profiles. So overall, the feature helps ensure optimal resource allocations for workloads based on specific computing needs. All right, next slide. So this is an overview of some of the key roadmap priorities for the second quarter and second half of the year. Just a couple items to call out. So first, we're continuing to enhance distributed InstructLab training on OpenShift AI, along with support for multi-node, multi-GPU training. In the next few slides, we'll cover some of the upcoming items like third-party model validation, model optimization, the model catalog, feature store, RAG and agentic plans, and expanded capabilities for managing GPU allocation and usage. With that, I will pass it over to Rob.
All right. Thank you very much, Jeff. So yeah, as Jeff was just alluding to, I'm very excited to announce the integration of LLM Compressor into the Red Hat AI product portfolio, coming out in dev preview for OpenShift AI 2.2 and RHEL AI 1.5. Customers will now have the ability to use LLM Compressor as a workbench image and a runtime image within data science pipelines to quantize models to a variety of formats, including int4 quantization, int8 quantization, and of course, FP8 quantization. For those that need a quick reminder, LLM Compressor is the open source transformers compatible library for applying various types of compression algorithms to LLMs for optimized deployment with VLLM. This library, enables ML engineers to apply different forms of quantization to enable LLM speedups while running across varying hardware accelerators. So really excited to announce this dev preview with the upcoming workbench image, data science pipeline examples, and of course, full documentation, which will be available on GitHub and releasing as a dev preview for our summit timeline. Next slide, please. Cool. And as well as Jeff just alluded to, we're really excited to announce the launch of the third-party model validation program, which will have a lot more information announced at Summit. But ultimately, the third-party model validation program is really about bringing customers the flexibility, confidence, and predictability in deploying the leading third-party models in the world on the Red Hat AI platform. So really, we're looking to take the leading models in the market, quantize them, run them on VLLM that is being shipped in our downstream products, and really give customers an understanding of what performance can look like when using the Red Hat AI product portfolio. So ultimately, it's about taking these leading models, running them on VLLM, and then giving customers confidence in deploying these across RHEL AI, OpenShift AI, across a ton of different hardware architectures. So we're really excited to announce this and really help our customers deploy the leading models in the market in addition to Granite. So really looking forward to this one as well.
In the first place, we're going to start surfacing all of that goodness is inside a new feature in OpenShift AI called the Model Catalog. So the Model Catalog is going to be a place for users of OpenShift AI to come in and take a look at external repositories like registry.redhat.io and in the future, Hugging Face, Llama, etc., and discover models, right? And this can either be an open format in terms of customers can go and see what models are on Hugging Face writ large, or it can be curated by an administrator to say, well, only these repos, only these model families, or only these specific models are available to be pulled into my cluster. In addition, this is where we're going to surface all of the model validation data to start. So customers will be able to get some insights into the performance of the models, some advice, access to the quantized versions of the models, etc. So we're really looking forward to bringing this out and watching this evolve over the next couple of quarters. Kezia.
Thank you. Speaking of models, so adding on to that, Feature Store, which is going to be coming out as a tech preview in 2.20, which is basically a centralized repository to organize and store and manage this data to serve to AI ML models. So this will be utilizing the open source project Feast, where users will be able to generate features or measurable properties from unclean data for model training and inference. So teams will be allowed to store and access these generated features while ensuring consistency across different models. So this centralization eliminates the need for data scientists to repeatedly compute the same features, leading to faster model development and deployment. Feature Store will also enable MLOps by standardizing and automating how features are handled across inference and training. And for DevOps, it'll provide a more predictable component for managing the features and simplifying the environment configuration and deployment for scaling. This will ensure infrastructure is easy to manage and replicate. And this will target consistency across training and inference, which will reduce data drifting and training skews, collaboration and reusability to reduce time and resources wasted, and lineage and monitorability to detect any training errors and support for reproducing. And I'm going to pass it to Adele.
Thank you, Kezia. So we're going to be introducing a platform-native RAG agentic workflow with Llama stack in the platform with Red Hat AI. So what does this mean, right? Kubernetes introduced the concept of API servers, where you can, with a lot of abstraction for deployed workloads at scale, with pods, deployments, even custom resource definition to extend with your own APIs. We're doing basically the same thing with Llama stack here as a unified AI API server. With Llama stack, you can reuse existing API, extend to add new APIs, but also add new providers. One of the main providers we're going to be focusing on is to provide you an out-of-the-box experience for RAG and agentic workflows. For RAG, you're going to get UX testing, RAG workflows with ingestion, retrieval optimization, and a reference DP that you can use for your experimentation, but also recommended partner DPs for production. And you're going to be able to bring your own vector DP. For agentic, you're going to get out of the box the reference agent implementation with session management, multi-turn, and steps, plus multi-agent capabilities. MCP will be built in with Llama stack, so you can point your MCP agent or application or AI application to an external SSE MCP server. Additionally, there are built-in tools for web search, code, and RAG even as a tool. Finally, client tools are also something that you can introduce, customizing. You can add your own functions to become tools part of the framework. Safety and checks are going to be part of that. We're going to be giving that through Trust AI Orchestrator workflows. And finally, all of this is built on a solid foundation. So whenever you're thinking about an agent framework, you need to think about those enterprise-ready platform primitives like observability, networking, and storage, which we build on top of the OpenShift container platform. So with that, I'll be handing over to Christoph to talk about GPU as a service.
Oh, thanks again. Hello again. So I'm going to talk a little bit about what we are doing in an infrastructure area of our product. We have heard about the expensive GPUs before, and we would like to extend and really enhance the management, the workload scheduling, the observability with regards to GPU intense workloads. That is why we have started an initiative to really work on the GPU scheduling on whole GPUs, on multiple GPUs, but also on fractional GPUs. Imagine an environment where data scientists just evaluate a model, need to start a model serving for a short term just to get a feeling of the model, interact with it a little bit, and tear it down after a short period of time. This is something where we want to enable them to use half of a GPU, for example. This is one side, one extreme of our GPU-based workload scheduling. The other one, I talked about that earlier, is, for example, model training with Kubeflow Trainer-operator and multiple GPUs. So really thinking about whole GPUs, multiple GPUs, but also fractional GPUs is our point here. The next area where we want to extend our support is that we are not looking at model serving to be scheduled by this capability or the training jobs, which are kind of non-interactive workloads, but also extend our capabilities into the interactive workloads. Imagine the data science notebooks that the data scientists use to work on models. They also require GPUs. So we want to schedule these workloads also by what we call GPU as a service by now, by the more sophisticated workload scheduling. Same for training jobs. We talked about that earlier. We have that in our product for quite some time now, but also batch kind of jobs and data science pipelines. All these workloads will be scheduled, managed, and observed by the same GPU as a service capabilities. The GPU idle reclaim is also an interesting feature we are working on. So we really want to provide a feature where unused model servings, for example, or unused notebooks will get scheduled down to the minimum amount that is required, maybe even to zero, so that we can free up resources to other workloads. Scaling down is a nice thing, as you can imagine, but also scaling up again. So if requests come into the model serving endpoint, we would like the scaled down workload to scale up again so that requests can be answered in an appropriate way. I think I said that before. The most important thing that we are trying to provide with this capability is the utilization increase. So the huge investment in GPUs should be utilized to a maximum. They should not idle. Another thing is that we want to have a very unified way to schedule different kinds of workloads with this capability. So really unifying and supporting the the AI lifecycle of models and training jobs and interactive workloads is a goal here. Lowering the cost is generally one of our focus areas. We have heard that with the model optimization. We are also repeating that pattern in GPU as a service, which is kind of an infrastructure scheduling capability here. With that, I'd like to hand it back to Shar, the master of the presentation, for some final words. Thanks.
Thank you, Christoph. Thank you, everyone. Thanks to my team for our team to presenting this, and hope to see you all next time. As we alluded to, I'll see if I can go back quickly to that. Let me see how good my capabilities are. If I have to go back to an earlier slide, but I think I can't. So, the slides are going to be available as well as the recording, and we hope to see you next time, which will be in Q3. Thank you, and have a great rest of the day.